We're way behind, so we'll start this recording here. All right. We're not behind. We're actually ahead of where I wanted us to be today, so feels pretty good. Wow, Emily, so that means we're gonna end early? No, absolutely not. Espacio, no. There. And stat 230. There. Wait, no, that's not what I wanted. Okay. Step away. I stole this, so no more chairs on the table. Snazzy, right? No, I borrowed it from the nurses, but there was no one there. I went to ask and there was no one there, so it must be Friday, right? I intend on returning it to where I found it after class. So, okay, it was just yesterday. Feels like just yesterday that we talked about, that's what I should have said, that we were talking about just establishing all this terminology. And today we're going to do a little bit more of that. I'm just going to jump right into section 1.3. I think we said we were going to continue 1.2, but we finished it yesterday. So I'm going to just get into 1.3. It's fine. And we'll finish chapter 1 today. 1.3 is called Sampling Principles and Strategies. We're just going to talk about kind of the core things and nothing too deep here, right? Because again, if you find yourself having to collect a sample, then it's its own thing. There are people you can hire to do that and that know what they're doing. And so just to play it safe, right? Especially in data science, as a data scientist, it's not going to be your job to collect data, right? It's your job to kind of find data and analyze data, but the collection is its own thing. So that's why we're just going to touch down and then get out of there. Okay. And so what we need to talk about though is in terms of sampling. So what is a good sample, right? Remember, a sample is that subset of the population where we actually get our information from, right? And so a good sample, and I say a kind of a good sample, good, it's hard to kind of say what good means, but a good sample is collected in a way that minimizes bias, okay? Is collected in a way that minimizes bias. Okay. So then that leads us to, well, what is bias? Bias is when you're systematically favoring an individual or some kind of group of observations to be in your sample. Okay, and so I taught a course on sampling at UBCO in December, and it was just a quick little 1-credit course, but we just spent 5 weeks talking about sampling. So you can see how it's its own thing. And really what we have to arrive at is, okay, we're never going to eliminate bias, right? We're never going to be able to collect a perfect sample. What's a perfect sample? Perfect sample is one that's representative of the population, right? And so here, maybe I'll add, we need our sample to be representative of our population. Okay. Right? Why do we need that? Because we're going to use our sample information But then we want to try to use that to learn about the population. If our sample is of our population, then that's really bad, right? And going back to that course that I was teaching, what I said was, if all this stuff doesn't make your head spin, then you're not thinking about it hard enough, right? We're never, ever going to eliminate bias, but we have to think about all these ways that we minimize bias. Okay, so that's going to be the most important part here, is that we're minimizing bias. So what is bias? We said it's when we're systematically favoring one or more individuals in our sample. There are lots of ways that we could introduce bias. Oh, here's my first freak out of the term. And it's only what, day, well, 2 of recording. I am recording. Sometimes I'll have this little panicking moment where, did I hit record? Did I do it? Am I on mute? It'll happen, but not today. Not today. Okay, sorry. So where can bias come from, right? Especially if we're sampling, then we can do a convenience sample. That's going to introduce bias, right? A convenience sample is when we just go out, and if I was tasked with serving students at OC, right? And I just ask you guys to complete my survey, that's a convenience sample because it's convenient for me to just ask you guys. I have you all here, right? But you are not necessarily a group that's representative of all students at the college, right? And so that would be bias. So bias can result from different things. Things like convenience sampling. There's non-response bias, right? So these are just some typical things that we need to kind of have up our sleeve and keep an eye out for, especially if you're reading a report, right? So someone sends you a report, or you're reading a study, then these are just things to look out for. But non-response bias. What's non-response bias? You try to include people in your survey, but they don't respond to you. They don't do the survey. That happens, right? As I said, I worked for a market research firm for 2 years in Victoria. And so we did a lot of social surveys, a lot of government contracts, right? So we're trying to get all these surveys done, right? How do you feel about your local parks, blah, 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 transportation, all those things. Most of the time, people just wouldn't respond, right? You try to raffle for an iPad or something like that. You're trying to increase your responses any way that you can, which again, you could argue that that's introducing bias because now people are more inclined to do your survey, right? It's just kind of, it sends you into a tailspin, right? But just remember, your goal is to just minimize bias, but also just to be aware and list all the ways that you could be introducing bias, right? Sometimes there's nothing we can do about, for example, response bias, right? There's nothing I can do about people not sending their surveys back to me or completing their surveys, right? So then in my report, what do I have to do? I have to confess. I had this many non-responses, which would affect my sample and make it less representative of the population, right? Because I didn't reach all the people that I tried to reach. On the flip side, there's response bias, which is kind of interesting. And I can't remember where I have them, but maybe I can hunt it down, but response bias. So now you actually managed to convince someone to do your survey. Awesome, right? Now you have to make sure that the way you ask the questions doesn't influence how they answer, right? Or, I mean, if you're doing a bad job, maybe you phrase your questions so that they answer in a particular way, right? And so, right, especially if it's a touchy subject, right? Money questions, kind of, if you're here at the college, right, any academic integrity questions, right, those would be kind of it's hard to get true responses, right? And so anytime that you're dealing with that, or you've worded questions in a weird way to kind of produce certain responses, then that would be response bias. Okay, let me just see if I can quickly dig up those examples that I had. These are from, oh yeah. Okay, so the wording. Okay, maybe I'll bring both in. Why not? We can read them. You don't have to copy. They're just for fun. Or for, maybe not fun, interest. Okay, so here, response bias would be usually in terms of wording, or kind of if you're dealing with a tricky subject. The first one is interesting, but too long for us to read together, so I'll go for this one. So they had a group of people that they had collected, randomly sampled into their sample. And so 13% of those people said that we're spending too much on assistance to the poor. And remember, we're asking the same people here, but then 44% of those people think that we're spending too much on welfare, which is what? It is assistance to the poor, right? And so it's just a choice of wording makes a huge, right? And so same, they had, right? You can kind of get the gist, but, or you've probably read it already. Okay, so what do we do if we're trying to minimize bias? How do we minimize bias? We minimize bias by collecting a random sample, right? And so, and it sounds easy, right? But it's not necessarily. I'm gonna just give myself one more line here. We minimize bias it's from my own personal archive. Yes. I stole it from somewhere a long time ago. It'll be in the notes, but it's just for just kind of interest, right? So, and I'll post these, but I go through teaching style phases. So I went through a phase where I had typed up all the notes, but then I felt like that got a little boring for you and for me. So then, probably mostly me. So now I just try to write out everything. Anyways, I go through phases. And remember, that's our goal. In order to have a sample representative of the population, how do we do it? By collecting a random sample. Okay. So that's going to be really important. Of course, a lot of work over time has gone into how do we collect a random sample, right? What is a random sample? And so by definition, a random sample is when each individual in the population that you're interested in has the same probability of being selected into the sample, right? And so I can kind of hear it before I say it. So it's good. So a random sample is when each individual has the same probability. Oops. Of being selected into the sample, of being selected, maybe I should say from the population instead. It's not what I have, but from the population in sample. And just as a reminder, right, why is this important? Well, a random sample ensures that the sample is representative of the population. A random sample ensures the sample is representative of the population. There are a few common techniques, and there are many more advanced techniques, right? But usually we can make do with these kind of simpler techniques. They do a decent job. And so the first main basic technique is a simple random sample, which we usually denote by an SRS. Okay? And so a few techniques, I just want to outline them here. Oops. To collect a random sample, we can do a simple random sample later on in our questions. It'll say an SRS of size 40 or whatever was collected. And that just means that it was a simple random sample. Okay. And I'll tell you what that is, but it's exactly what it sounds like. It's just a random sample from the population. Okay. What does that imply? It implies that you can assume that the sample is representative of the population, right? Or that's what we have to assume, right? Not necessarily the case, but we can assume that. Okay? And so here, it's a random sample from the population. Lots of different ways that you can collect a random sample from the population. A lot of the ways assume that you have, or at least a theoretical list of all individuals in the population, right? And so that's one of the kind of assumptions that we're making, right? But that's not always the case, but it's one of those things. So if we think about the college, the registrar, I mean, they can't access it right now, but they do have a list of all the students here, right? What courses they're taking, all that information, right? And so it exists. So we could pull a random sample from that list. How do you pull a random sample, right? My go-to way, right? If I have to pick a winner for a draw, I mentioned that we would, offer iPads or whatever. If you'd enter a draw to win this iPad or gift certificate or whatever, how do I draw those winners? Okay, I personally like to go to random.org because they claim to have the most random number generator. How come random number generators in Excel, they're not random at all, right? Even in R, you can generate random numbers, but a machine, we still had to program a machine and tell it what random means, right? That's not random, right? And so random.org's claim to fame is that they've developed the most random number generator. Weird. Anyways, so I would go to random.org. I would generate a list of random numbers, same length as whatever raffle I have. Yes?
I'm just curious, what's the difference between running an assembly program and that?
Exactly.
Yeah.
There's no difference. It doesn't matter. It's just so that when you write your report to the client, you can say you used the most random number generator. It's just for fun. You can use the Excel one, although the Excel one is notoriously not random. So
what about like Java?
Sure.
Math.random.
All the same. Someone still had to tell it what random is,
Yeah.
right? And so, but like I said, the only reason I use random.org is because it looks good when you say you use the most random number generator. Doesn't matter. I generate a list, same length as the number of people that I want to draw from, right? My population. And then I sort my list of random numbers, and whoever got number one is the winner. Bye. Right? And so, or what if I decided number 10 was going to be the winner? Doesn't matter, right? I usually just go for 1, 2, 3, 4, 5. And same thing, that's how I would draw a random sample, right? If I want a random sample of size 30, I would do the same thing, but then I would just take the first 30 from that random number generator, right? But lots and lots of different ways that you could do it. If you had all the names, if it was a small population, you could put all the names in a hat and randomly draw them like this, right? That's fine. You could roll a 6-sided die. If you roll a number 2, you're in my sample. If you don't, you're out. Lots of different ways, right? But they all rely on a random process, which we'll get to in, I think, chapter 3 or 2 or something. Who knows? Anyway, so that's going to be our go-to, is a simple random sample. You can also do a stratified random sample. I usually joke that it's abbreviated SRS. It's not. It's just a stratified random sample. That'd be confusing, right? So a stratified random sample is a little bit more sophisticated. We split our population into strata, which means that they are in like groups, right? Homogeneous groups. And then we randomly sample within each of the groups. That would ensure that you have representation from each of these strata, right? And so let me write that down here. The population is split into strata. And I'm not going to say homogeneous groups because it implies that all characteristics are the same, but with some characteristic in common. Then a simple random sample is collected from each of the strata. From each of the strata. They're not necessarily the same sample size from each strata. You can kind of play around with that if you want to. Typically we do use the same, but not necessarily, right? You might want it to be representative of the true population, right? For example, from the college perspective, yes.
Is it like clusters with same patterns of behavior?
So we do have cluster sampling as well. The difference between clusters is that they are just groups, whereas strata have some characteristic in common, right? All the strata. So for example, from the college perspective, right, the program that you're in would be your strata, for example, right? And so if you're in the sciences, right, you have that characteristic in common. If you are in arts, you have that characteristic in common. If you're in data science, you have that characteristic in common, right? And so whereas clusters would just be harder on campus, it would just be who's in what area at whatever time, right? That doesn't mean that you're in the same classes necessarily, right? Although it kind of does.
The Department of Science, Department of Management, Department of Health Science.
Yeah.
But they are clusters.
They're strata because they have something in common. There's and I've got a graphic actually to help with the difference between strata and clusters. But before I show you that, I want to introduce a cluster sample because it might kind of clarify some things. But a cluster sample, then the population is split into clusters. And so sometimes it's just a matter of how you want to argue things. But if you think about Kelowna, right, where people live in Kelowna, right, there's people who live downtown, there's people who live down here in the Mission, there's people who live in Rutland, right, Glenmore, right, those aren't necessarily, right, where you live doesn't necessarily mean anything about what program you're in at the college, right? And so then those would just be clusters. But so the population is split and a random sample of clusters makes up your sample. So here, here's another Emily Special, I guess, which I've stolen at some point. Okay. She'll just be in here. So stratified sampling is here, right? Notice that, right? The reason these are all orange and these are all brown, I can't really see the colors, but these look the same to me, they're not. I'll go with green, I can see the green, right? And so these are all green circles and these were randomly selected within those strata, right? These are all the red circles and these two were randomly selected from within. However, if you think about or if you look at the cluster sampling, all different colors, they're not homogeneous anymore, they're just inconvenient clusters, right? And so these here are clusters, but when we do cluster sampling, then we just randomly select clusters, but then we survey everyone in those clusters. So this is the visual representation of the two, which is kind of one of those things that's hard to wrap your head around. Okay, so, but that's also the difference between strata and clusters, right? I think if you were just talking to someone and you called them clusters, no one would bat an eye, right? But there is a difference. And the last one I want to mention here, just so that you are aware it exists, but usually it's kind of too elaborate, often too elaborate, but you could do multi-stage sampling where you do stratas within stratas, within stratas, within stratas, right? The simplest example would be if I wanted to sample from the departments, right? Sciences, arts, business, let's just talk about those three, right? So then I want to sample proportionally from all those departments, but then I also want to make sure that I sample proportionately by gender, right? Let's say a 50-50 split, for example, right? And so then I would have to further stratify within my strata, which is very kind of hard to wrap your head around, I think, and we rarely use it, but it exists, so I'll write it on here. There's lots others, but multi-stage sampling is when you do multiple layers of stratified random sampling. Okay. Like I said, its own fields. You can read tons and tons and tons of books about it, but it won't really be your job to collect data anyways. And so you don't have to truly worry about it. Same thing, section 1.4 is on experiments. And I think I mentioned it last day, but it doesn't hurt to mention it again. You can read the little blurb. It introduces terms like placebos, right? But I think we're all aware of placebos, right? If you're doing a medical study, if you watched any medical drama, but what if they get the placebo? Right, and so we kind of know what the placebo is, and all those kind of terms, but it introduces them. I'm not going to go into it. Besides that, right, medical dramas, the placebo is when you get a fake version of the drug to see if just you need a control, right? Can't just give people drugs and say, oh yeah, they totally worked. No, compared to what, right? So you need some baseline. Then there's the placebo effect. Oh boy. All I really want you to take home about experiments is that it's the only way that we can establish a causal relationship, right? This caused a change in this, right? And so, wait. Experiments are the only way to establish a causal relationship between two variables. That's all I'm going to say about experiments. That's all we will say about experiments. Kind of gets weird because we started late. I blame Bevan. Usually it's my fault, but it's nice when you have someone to blame. And so I feel like I can't really end early in an early class, but so here we go, chapter 2. We'll just start it I'll review it on Tuesday, obviously anyways, but it's good to have a heads up. In terms of homework, that's something that I wanted to talk to you about because I have all these beautiful assignments set up in my Okanagan Math, which is on our servers and inaccessible. Steve has this theory that it exists and is running, but we just can't get to it. So that's a problem. So I can't set up your assignments. So if it keeps going into next week, then I will assign practice problems. But for this weekend, just enjoy the weekend and don't worry about this course. But I don't want to finish quite yet, but I did want to say that before I end it. Chapter 2 is on, I'm just kind of banking on them getting it up and running. We can put it off a little bit longer. Is on summarizing data, right? So now we've talked, okay, how do I collect data? Sort of. How do I talk about a data set intelligently? Now I want to summarize my data. Where we're going to start is with numerical data. Numerical data are things like measurements, right? So usually measurements, speeds, weights, heights, grades, right? If we're talking about your percentage grade, not your letter grade, right? But your percentage grade. And so these are our measurements, such as speed, distance, weight, percentage grades, etc. So let's talk about grades. That's something that we can easily wrap our head around, right? And so if you consider a list of grades, the grades variable will be numerical, right? The grades variable, and maybe I'll say grades. I can't really italicize it. Usually if it's a variable name, we can italicize it, but I don't write that fancy. So is a numerical variable. Yeah. What's the number one question that you usually ask me? What's the average, right? Because you know that grades are numerical and we usually talk about the average to summarize numerical data, right? And so, right, we usually use the mean. It's the first time I'm saying that, right? But it's probably not the first time you've heard it. But it is the average. Usually what I do is, especially in the beginning, is I say them both. It's redundant, but just to get that link for you guys, and then we'll use them interchangeably, right? Depending on what sounds nicer is usually how I choose. There's no rhyme or reason, right? So we usually use the mean or the average to summarize numerical data. For us, especially in the textbook that we're using, we usually use an X as a placeholder for a variable. Now in upper level stats, you're likely going to use Y's. I don't know when that switch happens, but it happens at some point, and just be aware you can use anything as a placeholder for a variable, right? But in general, a variable and I'll say such as grades, right, is often generically denoted by a lowercase x or uppercase X. I know, it gets confusing. Is often denoted by I'm gonna use a lowercase x. It's kind of itty bitty steps. And I like to do a little, put a little Irish on it, right? A little tilt, like a little, yeah, it's a little tilde on my x, because people are still sometimes using x as a multiplier. I do not want you to do that. I don't want to see that. But just to kind of emphasize that it's the letter X, I put a little spin on it, okay? And so if we want to talk about the mean of a variable, which is how we summarize a numerical variable, we put a bar over it. Okay? And so put it here. The mean of X is denoted by X bar. Oh, I shouldn't do it so sloppy the first time. There. Okay. Anything with a bar over it means that you're talking about a sample mean. Okay? The sample mean of X. Now, let's see here. Wait. Anything with a bar over it, in statistics, I should say, denotes the mean of what's underneath, right? Under the bar, of what is under the bar, right? Or the average of X. What's that? Your average smiley face. That's my go-to. There, I said average. A mean smiley face. Now there's a joke in there somewhere. Mean smiley face, but it's the average smiley. All right, there. Like I said, we'll pick that up on Tuesday. Have a great weekend. We'll see you then. Oh, and of course, if you have any questions, let me know. But I'll stop this.